Think kind of bam bam. It's because I'm Jamaican. With a different style, different fashion. You know? Come and say one thing, Nancy can't understand.
Amirah binti Azzyati. I'm Airina binti Azzyati.
And my name is Raja Julziad. Hi, I am going to explain to you the process of osmosis. Osmosis is the movement of water molecules through a semi-permeable membrane from a high concentration gradient of water molecules to a lower concentration of water molecules. Tonicity. Tonicity is the measure of osmotic pressures of two solutions across a semi-permeable membrane. Like osmotic pressure, it is influenced only by solute. For example of solutes, we have sugar, salt, and others. There are three classifications of tonicity, which is hypotonic, hypertonic, and isotonic. For hypotonic, the concentration of solute inside of the cell is higher than outside of the cell. Therefore, the water molecules goes inside of the cell. As a result, the cell becomes larger. If the water molecules continuously moves into the cell may cause lysis or rupture. If the solution is hypertonic, the concentration of solute outside of the cell is higher than inside of the cell. So, water molecules from inside of the cell goes out of the cell to the surrounding. As a result, the cell shrinks. If the solution is isotonic, the concentration of solute inside and outside of the cell is the same. Although there is a continuous movement of H2O inside and outside of the cell remains the same.
Assalamualaikum. So for today, I'm going to present to you an experiment done by the process of diffusion through the plasma membrane of the egg. So to begin this experiment, you are required to immerse this egg inside vinegar for 48 hours so that the shell of the egg will be dissolved and the membrane are totally exposed. So the point of this is that I have taken 3 eggs, one being the control experiment, one being immersed inside a solution which is hypotonic to the egg, and the other one in a solution that is hypertonic to the egg. So for the solution that is hypotonic to the egg, so we're taking this simple substance which is water, while for the hypertonic solution, I've taken the oyster sauce. So as you can see that I have immersed it inside the hypotonic and hypertonic solution for a total of 48 hours, and the result is you'll see that you observe that the egg inside the hypotonic solution will be slightly bloated, right? So I'm comparing this to the egg immersed in the hypotonic solution with the control egg, so which is slightly bloated. You can feel it a little bit like squishy compared to this one. This is because the water has went inside of the egg through the plasma to the membrane, and the water has went inside here, while the one that is inside the hypertonic solution, which it will be like slightly flaccid. Let's see. Yes, there it is. So the egg is like slightly flaccid. It's like a bit airish compared to the control experiment. So you can see that this solutions has caused the water passing through the membrane inside the hypotonic and hypertonic solution. So that pretty much sums up diffusion across the membrane of an egg. Thank you. Hi, today I'm going to give a brief explanation on diffusion. So diffusion basically means is the passive movement of molecules along a concentration gradient from higher concentration to a lower concentration until it becomes equal. So for today, we are going to explain the factors that affect the rate of diffusion and the 2 parameters. First off is viscosity, second is temperature. So under viscosity, we are taking 2 solutions, which is the starch solution and the water solution. So you will see that in the starch solution, it will be harder for the dye molecules to diffuse inside, whereas it will be easier for it to diffuse inside the water solution. greater difference in concentration causes more rapid diffusion. So the closer the distribution gets to equilibrium, the lower the rate of diffusion. So in the starch solution, since it is concentrated and the dye solution is concentrated and the concentration gradient is not as high compared to water and the dye solution, so it makes it harder for it to diffuse inside. So secondly, under temperature, we are taking two different temperatures of water, which is hot water and cold water. So you will see that inside the hot water, the dye will make it very easier for it to diffuse, whereas in the cold water it's a little bit slower to diffuse. Why is this so? Because as high temperature, it provides energy for the molecules inside the water. So when the dye molecules enter the water with high energy of the molecules, it makes it easier for it to diffuse through. But then in the cold water, we'll have lesser energy, making it hard for the dye, making it slightly hard for the dye molecules to diffuse inside.
Hi, Assalamualaikum. Today I'm going to represent to you an allocation factor that can affect the rate of diffusion. Like Airina said just now, diffusion is the movement of one molecule to another molecule through a different concentration, which is called medium. Okay, the thing that we use in this experiment is two glass and two different concentration with different temperature, which is the cool water. The cool water is room temperature, and the second one is the hot water, and the third one is the dye, the red dye, and the fourth one is the sponge. Okay, firstly we need to put up some hot water in the glass. Okay. The second one is the cool water. Okay, next, 1 spoon of dye. Okay, let's pay attention to it and see how fast they become totally homogeneous, to have red color and to distribute to the entire glass. You may notice that on the left hand side, where the water goes, sometimes you can find out the dye is simply stagnant and not moving at all. Okay, however, at the right hand side, you can see that they mix up in the homogeneous solution. This shows that on the high temperature, the dye molecule will be able to move around and drain it effectively so that it can diffuse very well. But on the left hand side, the cool water, which is the low temperature, the diffusion occurs much more slowly. Again, okay, this is our second experiment. Okay, for this experiment, we have to test whether viscosity can affect the rate of diffusion. So we use different concentration, which is water, and this one is the starch solution, which is very viscous. Okay, now we put up some water inside the glass. Okay, and the second one we put up the starch solution into the glass. Okay, next we put up some dye inside this solution. Now you can clearly see the difference. On the right hand side, it's just the water which is relatively low viscosity, and you can find that the dye will move around a little bit and very effectively. But if you look at the left hand side, we will see the difference, which is in very viscous starch solution, you can find that the dye is on the top and it is not moving at all. Basically, it has a hard time diffusing over distance. However, the diffusion still occurs in this solution, but it much slowly than in the water. Okay, so that this experiment proved that the high viscosity will block diffusion rate effectively.